see. So just to introduce, I've got 4 panelists today. So I'll just introduce them, and then we'll, similar to the way that Kuhu, the last session ran, each of them will make about a 2 or 3 minute, 2 or 3 minute kind of key message on different sort of elements of climate change and opportunities in the EGP, and then we'll take some questions within the panel and then open it to the floor. So I have with us today, we have Brian Dawson, who was the Climate Change and Energy Advisor to SDIP. And I think I can speak for everyone that knows Brian. His knowledge of climate change is encyclopedic, so I'm looking forward to him sharing some of that today. We have Ram Dalal, who's a professor in the School of Agriculture and Food Science at UQ in Brisbane. And he has a particular interest in soil carbon and has led Australia's National Soil Carbon Program, among other things, and has also obviously been working on the SRFSI project. We also have Apurbo Chakki, who's a scientific officer in the On-Farm Research Division at Bari in Bangladesh, and he's just returned to Bangladesh after completing his PhD at UQ, where he was looking at using AppSim for modelling farming systems in Bangladesh. And finally, we have Mahesh Gattala, who everyone knows, who's worked with SRFSI. So I'm hoping Mahesh can bring the kind of farmer's perspective into the conversation. So I'm going to start with Brian to give us the kind of big picture about how climate's changing and will change in the EGP and how this might impact agriculture. So just to remind you, you've got about 3 minutes.
Okay, thanks.
Brian.
I'll try.
Brian, you might just have to turn off your video.
Oh, yeah.
Yeah. We can hear you now.
Okay, all right. It's pretty clear that the climate is changing and is going to continue to change for some time. The recent IPCC report paints a pretty stark but clear picture on that one about how climate has changed and will continue to change. It's also clear from the most recent report that options to contain warming do exist. You contain it to less than 2 degrees, that is, but clearly a major challenge given the amount of emission reductions required. So really the IPCC report, most recent one, provides a very good picture of what's going on, but it doesn't really change the underlying story of what's been in the reports for the last 3 or 4 versions. So it's just a bit more accurate and much stronger evidence base. What is clear, the models have become better, but in general, they've tended to underestimate the potential for excursions from the norm, like extreme weather events. And this is recent evidence in the fires and heat waves and, extraordinary temperature excursions that are, 1 in 100 year or 1 in 1,000 year events, as well as rainfall intensity and floods. So it's supported by the evidence. In terms of the East Gangetic Plains, it's pretty well documented through this project, through various reports and the summary report, what the expected changes are. These haven't really changed much in the last year or 2. Some of the key highlights are that it's probably 1 to 1.5 degrees of additional warming by 2050. Precipitation, still uncertain, but likely to be 10% or more, mainly in the monsoon. Winters are probably likely to become drier. Evapotranspiration could be 5 to 7% higher by 2050. And weather extremes, particularly heat waves and temperature extremes and rainfall intensity and floods will all increase. So overall, there's quite a few climate risks. Variability, one of the issues that's been a bit uncertain for some time is the monsoon and the timing of the monsoon. And its recent modelling and evidence suggests that delays of days to weeks are likely to become more prevalent over the next few decades. So overall, all these present pretty significant challenge, but I'd say that extreme weather events, particularly heat waves and extreme heat and rainfall intensity, are likely to be the 2 largest impacts in the short to medium term for agriculture in the East Gangetic Plains. In terms of impacts, this is an area where I think this project's been excellent in shedding quite a bit of light on what potential impacts these sorts of changes will have, like on terms of the sensitivity of crops to heat, pest and disease changes. A little bit is known on that, but not much. Extreme rainfall events, water availability, critical infrastructure loss, all those kind of issues are all potential threats to agricultural production and livelihoods. I guess CO2 fertilisation offers some potential for yields, but it has trade-offs as well. So one thing that is quite clear is that the climate will change and crop suitability will change over the next few decades. Past 2050, even if we are able to constrain emissions, it's likely the ability of the region to produce grains is certainly going to be compromised. So managing this risk going forward is pretty important. In terms of the overall project, I must admit I'm quite impressed with the results achieved, in the climate change related issues and outcomes. Mitigation, modest gains, but a lot of potential if taken scale. I mean, 10 to 20% reductions are pretty good. Soil carbon benefits are likely if CASI is applied over time. And, I think to get a better understanding, I think on the carbon dioxide front, it's pretty good, but on the nitrous oxide and methane front, I think we need a bit more research and evidence to really get a more complete picture of the footprint. I think the project's also delivered on the adaptation side some really good resilience building benefits through the adoption of the different technologies and management approaches. And I think its contribution to the knowledge base has also been quite important. There's been quite a lot of studies and research coming out to shed some light on what's what's happening in climate change, what the impacts will be. So overall, quite impressive in the results, and quite happy to answer any specific questions if people have them. Thanks.
Thank you, Brian. That was a great opening, setting the scene for how things are likely to change in the EGP, as well as some of the highlights of SDIP. So thanks for that. It leads quite neatly into Professor Ram Dalal's comments. He'll be talking a little bit about the importance of soil and fertilizer management related to emissions. So Ram, I'll share your slide that you sent previously and you can start talking.
Hey, Tamara. Yeah. Thank you for your introduction. I think what Brian has said is just fits in what I was going to talk about, that there would be an increase in temperature, precipitation would be different, or it may slightly decrease. But we haven't got a lot of idea about the greenhouse gas emissions. What would be the change in the long term? Here I present a fairly simplistic picture of what could happen. In this one, what it shows is the two problems we have looked at for almost 8 years now: the soil acidity, the acidification that's happening, fortunately rather slowly. But I think there is a report on small research activity we did, and that report should be available to the reviewers. I think Tamara, Neil submitted that late last week on the aspects of, we looked at the fertilizer part of it, especially nitrogen, phosphorus, and sulfur, nitrogen, phosphorus, potassium, and the zinc aspect of it, which is almost 80% is responsive, and 60% of the areas are deficient in zinc supply. We went out and had a look at in Bangladesh, West Bengal, and Tarai, Nepal, where especially in Bangladesh, Rangpur and Dinajpur districts, as well as in Cooch Behar, there was a certain response to zinc to the about 0.5 to 1%, 0.5 to 1 ton of yield increase or rice yield increase from zinc fertilizer application, but no effect on increasing the grain zinc over there. The other aspect we have been talking about for some time is the acidification that's occurring there, and Tamara presented information from there on Friday, where she indicated that we feel that in the next 10 years, maybe a bit further, that soil acidity will be a major issue as a soil constants to crop production. And there here we looked at in terms of nitrous oxide emissions. Here we looked at two soils. One soil is pH 5, and then we believe that with acidity, one option is adding lime. So we added lime to raise the soil pH to 6, and we found that there was a decrease in nitrous oxide emissions to up to almost 80% when the soil was at field capacity over a 1 month period. The other alternative we have, the management part we are looking at is the management of nitrogen fertilizer, because of the intensification of cropping. There is likely to be increase in nitrogen fertilizer use, and from there will be leakages in terms of nitrous oxide as gas, other than the percolation through leaching and increasing acidity. So there are the problems looking at acidity part of it, looking at how you can manage it, and what are the consequences if you don't manage the acidity in the longer term. So what it implies is that there would be increase in nitrous oxide emissions, rather significantly, and that will include to contribute to greenhouse global warming effects. That not only the loss in terms of it's lost as global warming, but also the loss to farmers in terms of the fertilizer nitrogen use. So we look at the nitrogen use efficiency, and the other part of the graph we showed is that you can use N-Tech fertilizer, for example, that is DMPP, the dimethyl pyrazole phosphate, that reduce the loss of nitrous oxide by 70 to 80% again. So what we are suggesting is that as the nitrogen application would increase over time, there should be efficient use of that nitrogen, which also will reduce the acidification part of it, as well as the contribution to greenhouse gases as nitrous oxide, which is almost 300 times more effective in global warming than carbon dioxide does it. Thank you.
Thank you, Ram. Some great points there, and I think it's really interesting to see how you can think about nitrogen fertilizer from so many, that acidification and the links between nitrogen fertilizer have so many different elements to it. Mahesh, I'm going to pass over to you now to talk a little bit about farmers' experience with CA and climate and some of the results that you've published as part of SRFSI.
Thank you, Tamara. If you go back, when we started conservation agriculture system intensification practices in Northwest and other parts, we never looked at, beyond the yield and profitability. But with time we realized that CA can be a part of, climate change mitigation as well as adaptations. If you look at that, because seeing is believing. So one is that mitigations, which is well documented through our publication, that it gives, clean energy because it's reducing by 42% energy use by, especially from fuels and then agrochemicals, resources and savings. and natural resources and pumpings and all. It saves water. Water is very difficult in Northwest as compared to Northwest to Eastern because it's more rain-fed and high rainfall, which is provide very less window, in saving of water, but still there is a saving. But that's why we need to look at beyond irrigation water saving to runoff and percolation and recharge as a impact large scale. But we will come on, that's clearly say that through these practices and on-farm practices, our data is saying that we can, harvest more with less global warming potentials and then energy, which is well documented through on-farm results and then by saving from that. But this is more important for policy and then for researchers and then to meet the mitigation strategy. But for farmers' point of view, adaptation is more important. And we never looked at CA as adaptation strategy. If you look at that, because and there is one saying I always quoted that conservation agriculture, good is in good year, but very good in bad years. And that seeming is believing, because if you look at that, after 3-4 years, we will get bad years in terms of drought, in terms of flooding and all. And then we realize that how CA can be mitigated in terms of flooding and drought and mitigations, and then against to fight storms and all. So we need to look at those and document. And we clearly found in Eastern Magnetic Plains well doing the farmers practice and all. So that's very important, how we can bring this CA as a kind of mitigation and adaptation strategy. And that's why some of the states and some regions, they include CA as a climate smart technology, which will be very, encouraging and helpful in future, that this will be, help to do, this adaptation as well. So that's one. And if I go on that, that's how we look at that, this as a large scale impact through simulations and all, to look at more kind of, because sometimes we look at small pictures but that's have a bigger impact as a kind of a scale that we need to be look at as Brian is mentioning, that we need to look more on that, how these CA and these smart technologies can mitigate or adapt, on climate resilience in future as well. I will come back if there is question. So thank you very much at this point.
Thank you, Mahesh, for those clear messages and about the on-farm research that was undertaken in SRFSI. And I think, again, that leads neatly to Apurbo, because you've been working with AppSim and modelling. So can you give us a sense of some of the modelling of crop performance under climate change that you've been undertaking?
Thank you, Tamara. Thanks for giving me the floor. For the start, I'd like to thank Dr. Donald Gaydon from CSIRO, who lead the AppSim climate change work for the SRIFC project. And I'm just part of that analysis. Anyway, climate change is a reality, and farmers in the Eastern Gangetic Plains have started facing it. And we used these AppSim tools to quantify what will be the impact on current cropping systems of farmers growing. As the AppSim modeling tools takes into account the effects of increased daily temperatures, changes in rainfall, and the effects of carbon dioxide fertilization. So our AppSim analysis has shown that yields of winter crops, like wheat and maize, will decrease in the harsher climate and in the increasing time frame, say for 2090, and the Kharif rice is the opposite trend. In the future, climate will be benefited for carbon dioxide fertilization in Kharif rice. So both positive and negative effects, and the main causes decreasing the wheat yield is the shorter winter season, and the increased grain sterility due to terminal heat stress in wheat. So there are differences across the sites. Some sites the impact will be more, the negative impact to wheat will be more, and some sites is less. So this is due to the local climate, and the differences have been particularly how much current wheat growing temperatures are to heat stress level. That's the main driver decreasing the wheat yield. For the rice, I think across the sites we have considered for our analysis, the rice crop will be benefited due to carbon dioxide fertilization. Yeah, that's it. I think that's the major part of our analysis on climate change.
Okay, thank you, Apurva, and thanks all of you. Before we open it to the floor, I was wondering if any of you in the panel would like to comment on things that the other panelists have said first. Does anyone have any comments or questions for the other panelists? If not, we can open to the floor. Do we have any? If you want to ask a question, you can either put it in the chat or raise your. Yes, PK has a question.
Thank you very much. Again, very interesting session. A very good analysis have been done by the authors. Just one point, here it has been mentioned that rice, wheat, and maize. What I feel that the adaptation and mitigation will also depend upon the farming system or what kinds of commodities are there in the system. So I think the analysis should also be taken into consideration that what are the promising crops which are expected in that particular region. That will be helpful for scaling up of many of the conservation agricultural technologies. Thank you.
Thank you, PK. Does anyone in the panel want to respond to that first? Or we can take it. Yes, Mahesh?
Thank you, Dr. Joshi, for this. This is very important. And then if you look at then in the Eastern Gangetic Plains, because we are recommending as a crop diversification that instead of rice, we are recommending in where it's possible, not everywhere, but in a plains and all, rice-based system is coming very forward. And we did some, comparison studies and all that. And there is no doubt about that. This new cropping system, it's very, very, kind of more adaptive or mitigative. I'm not saying it's adaptive because rice system is highly adaptive and sustainable too as well, but more on mitigations that it's reduced global warming potential in many folds in rice maize compared to rice systems and all. So yes, it's total farming systems. Also, it's, if you include livestock and then other part, fisheries and all, and that will give more picture that need to be looked at on bigger scale, at farming system levels. I do agree on that.
Fruits also.
Yep.
Yes. And Ram, you would like to make a comment?
Yeah, I support what Mahesh has just mentioned. And certainly if you got rice and another cereal, either wheat or maize, followed by some pulses or legumes, which certainly would be the way to go, because some of the nitrogen that pulses or legumes can contribute, then you put less nitrogen in the system and reduce acidification, reduce greenhouse gases in terms of nitrous oxide emissions. And it also balances your protein needs from cereals and legumes. And that has been one of the sad factor of these, what we call it, minimum support price systems that's been in operation in India. They got an example of Punjab, Haryana, where they used to grow a lot of pulses, where water was much less available. Now pulses are replaced by mostly rice and wheat. So that's another way of how the policy change can make a difference in terms of your climate smart agriculture. Thank you.
Thank you, Ram. If there are no other questions, I will ask the reviewers now if they have some comments to make.
I had
Sorry, yes.
comment. Can I make?
Yes, please, Madhav.
Yeah, hello everyone. Listening to the panelists, it seems to me that to address climate change challenges, be it in mitigation or adaptation, technology will play a major role. So it will be one of the major indirect driver. I think diversification clearly helps in adaptation and mitigation. So the expected higher impact on wheat crops, I think requires perhaps diversification, maybe with pulses and oil seeds. The less on rice crops, I think the drought tolerant and then flood tolerant varieties will be more needed. So what I'm getting at, the technology has to be given a very important consideration in this whole game. But at the same time, I think institutional frameworks have to be also be crafted, because we will need more interdisciplinarity and cross-disciplinarity to address this climate change. So I'll stop there, but very good presentation. Thank you.
Thank you, Madhav. Christian, I can see you've got a question or a comment.
Yeah, look, thank you very much for the discussion. It was a very interesting set of perspectives. I guess I just wanted to put a proposition to the broader team, and that is, yes, building on what Madhav just said, technology is going to be part of the solution in an adaptation sense, and certainly also in a mitigation sense. I guess when I just listened to what I've heard over the afternoon, and also what I've read up in the documentation, one thing that I think needs to be recognized is that at the farmers level, at the livelihood level, the way we tend to frame climate change, and if it's IPCC, or the way that if you like, at one extreme Brian's articulated it, a lot of those articulations or framings of climate change don't necessarily resonate in a place-based system where people experience climate not through a longer term perspective but through weather. And in my experience, and this goes back particularly to the work that was done in the ACCA project, farmers are very avid observers of weather, and they are very good at understanding what's happening. They may not always have that very long-term perspective. So I guess in moving forward, whilst you as scientists have to have a toolbox of possible technology responses, recognize that it's the choice that farmers make in how they might want to adapt, not what we push, but what they might see as being viable adaptation strategies. And I would argue that mostly those adaptation strategies will always be looked at from a livelihood portfolio, not from a CASI or this or that perspective. So there's a risk that, if you're captured by your technology push, you might underestimate that there's actually quite a lot of autonomous appetite and ability to adapt within farmers. So finding that sweet spot between, if you like, being there to offer options, but letting farmers make those choices rather than imposing or predisposing the options that they need to follow. And the CASI debate sometimes disturbs me in this context, as it's sort of something that is preached or is, you have to do this. Well, no, sorry, you don't have to do it. Farmers will know best how they might want to adapt. So I guess it's just a reminder to us all that we need to keep that in mind and recalibrate us, and perhaps just also be mindful of how we frame these things.
Thank you, Christian. Does anyone in the panel want to respond to that? Yes, Brian?
Respond. May I also add something?
Yeah, I think, Christian, I fully agree with what you say, and that's not only in South Asia, but across the world. A lot of the climate change engagements have been, it's up to the individuals and the farmers and the communities to make their own judgment about what's best. There's a number of drivers. I mean, technology is part of the toolkit, but it's also the enabling environment, the policy environment. There's so many drivers in terms of pricing incentives or disincentives or distortions. So you really need to take a more holistic view of the enabling environment, and farmers will be smart and they'll make decisions what has a higher rate of return, has a lower risk over a number of years, but they'll also be guided by the prices they're getting for their products and the incentives, whether it's subsidies or whether it's taxes or whatever is in place. And I think when you're looking at agriculture in the East Gangetic Plains, you need to look at not only what Cassie can deliver in terms of the toolkit, but how can the perceptions change in terms of the broader policy environment.
Agree.
Thanks, Brian. Farah, did you have a comment? And then we might.
Yeah.
Yes, I did have a comment. My 2 points. One is that farmers should have access to the information. I mean, I agree with Chris on the ability to participate and choose because it's tested and proven. And I agree on that point. And also, it's critical for them to have the information. But what we find on the ground is different lobbies pushing, because we're talking about climate smart agriculture, but in reality, the farmers want climate sustainable agriculture. So these are, there have been experiments on hybrid and this seed and that seed, and unfortunately, not all of them have resulted. This is one dimension. The other is that in the area of climate change, we need to have the global leadership. We are asking farmers to adapt, but the rest of the world is continue to behave as business as usual. That's not going to be the solution. We can come up with as many tools as we like, but when you have such frequent and intense disasters, and on one level, slow onset disasters, on the other repeated and frequent and intense disasters, and IPCC 6 report is now clearly attributing it. So enough of the conversation of is it climate change or is it natural? But I think in this, when we end or when we send a recommendation, we also need to think about the loss and damage, because what is happening as a result is the damage part we can maybe compensate and share, but what is being lost, how are you going to revive and bring it back? So if there's a collective paper coming out or a recommendation for policies, I think that's where we need to also take the conversation when it comes to climate change, adaptation, mitigation. And we want new and additional funding, not taking, robbing Peter to pay Paul. Don't take the adaptation money, mitigation money, but additional funding to deal with the climate change. Thank you.
Thank you, Farah. I'm going to hand over to Aditi for just one quick comment, and then we might wrap up, unless, Kate, you've got something really a burning question.
No.
Yes,
No, I just wanted to say +1 to Farah, because I mean, adaptation has to be looked at from the perspective of mitigation. And perhaps to answer Christian and others, what's also required is some kind of like a meta review, and I know Kasi has done some of it, many others have, like of the various options that the farmers have available, which ones are the ones that actually are the best at risk reduction. And while the literature in adaptation, and I'm saying this because I'm right now doing this analysis for our IPCC chapter, which is due to be submitted this Friday. So I'm at the very thick in the middle of that analysis. And what exactly is this meta review of over 1,000 case studies is saying that we know adaptation has several benefits, also disbenefits, but if we look at the benefits, what we don't know if any of those benefits also translates into climate risk reduction. And I think that's a big methodological gap in our understanding of whether adaptation reduces risk. So that's something I think we need more research investments in. The other thing is that we don't have enough studies that says, will our current adaptation even work in a 2 degree, 3 degree warmer world? I mean, what the studies are showing is that for many of these adaptations, the effectiveness would kind of decline sharply beyond 1.5 degree. So we keep coming back to this entire thing about the importance of mitigation and stopping emissions right now. From a science perspective, I would really see if our group can invest in studies that are actually doing future projections of adaptation at different degrees of warming. And those are the kind of studies we don't have enough in our region. We have quite a lot of them in the developed countries, for instance, but not really in developing countries. So, yeah.
Thank you, Aditi. I knew you would have something good to offer to this session as well. So thanks for that. Thanks to the panelists and all the questions. If there are other other questions, we'll get back to you if they've been put in the chat. I think now we will take a 15-minute tea break and come back. So 15 minutes, 5 o'clock Canberra.